Hello everybody, I am Dr. D.S. Gaikwad. Today I am going to take a lecture on topic mass spectrometry. That is for MSc second year, semester third students, organic chemistry students. First of all, we will see what is mass spectroscopy. Actually, initially we have the topic name is mass spectrometry, but mass spectroscopy is also called as a pseudo spectroscopy because spectroscopy is based on total the interaction of matter with the light. But in mass spectroscopy, the light is not used. It means actually electromagnetic radiations are not used. In that mass spectroscopy, high beam of electrons are used. Okay, so that's why mass spectroscopy is also called as a pseudo spectroscopy. Okay. So first we will see what is mass spectroscopy. So spectroscopy, it is a branch of science that deals with the study of interaction of matter with the light. So we know that electromagnetic radiations are divided into total 8 different parts. That is microwave, infrared radiations, near infrared radiations, visible, UV. UV is also divided into 2 parts: near UV and far UV, ultraviolet. Okay, X-ray and cosmic rays. So this is a band of electromagnetic radiations, and from these electromagnetic radiations, some of the radiations which are used in the spectroscopy. Okay, so radio waves generally these are used in nuclear magnetic resonance spectroscopy, that is NMR spectroscopy. So for what purpose they are used? So to obtain the exact number of carbon and hydrogens, means the different types of hydrogens and carbons we can determine from the nuclear magnetic resonance spectroscopy. The infrared spectroscopy is used to determine what kind of functional group is present in the molecule, whether it will be an inorganic molecule or organic molecule. Okay. And from visible spectroscopy, we can determine the conjugations, means how many types of the number of pi bonds are there. So from UV visible spectroscopy, we can determine that one. Okay. So now we will switch over to the mass spectrometry. Okay. So in mass spectrometry, as you see in the lowermost side of the slide, the high beam of electrons are bombarded on the organic compound or inorganic compound, and they are fragmented into the many fragments. So different types of ions are formed in the mass spectroscopy, such as parent ion, molecular ion, radical ion, radical cation, daughter ion. Okay, so the molecule is fragmented into different types of ions. So the main what is the purpose of the mass spectrometry? So the main purpose of the mass spectrometry is to determine its elemental composition, okay, and molecular weight of that compound. So from that we can also determine the unknown compounds by determining its mass to charge ratio, by the use of mass to charge ratio, or from that we can determine the mass of the compound. Okay, and the additional advantage of the mass spectroscopy is to determine the isotope ions such as chlorine, bromine, iodine. They specifically give a specific peak in the mass spectrometer. Okay, so this much information is obtained from the mass spectroscopy. So what is the basic principle of the mass spectrometry? So the basic principle is that in mass spectrometry, the high beam of electrons are bombarded on the organic compounds or inorganic compound, and they forms different types of fragments, and these fragments are detected by the detector. Okay, then we will get a graph that is with relative intensity or abundance of the ions to the mass to charge ratio or mass. So the basic principle is the most accurate method for determining the molecular mass of the compound. This is the best method to obtain a mass of the organic compound or inorganic compound. Okay. And in this techniques, as I said earlier, molecules are bombarded with a beam of high energy electrons. Okay. So the mass spectroscopy again further divided into two different types. That is, if that mass spectroscopy is attached to the gas chromatography, then it is called as an gas chromatography mass spectrometry, and if it is attached to the liquid chromatography, then it is called as a liquid chromatography mass spectroscopy, that is GCMS and LCMS. Okay. So this is the mass spectrometry experiment. As I said, the sample is injected into the ionizer. In ionizer, high beam of electrons are bombarded on that, and it converts into the ions. Okay, and at the last, they are detected in the detector. Okay. So this is the basic instrumental diagram of the mass spectrometer. Okay. So as I said, fragmentation process, bombardment of molecules by an electron beam. First 10 to 15 electron volt energy is used, and in that only ionization of the organic molecules takes place. Okay. And then when you increase the energy of the electron beam 50 to 70 electron volts, then the initially formed molecular ion is again converted into its fragment ion. Okay. So these are the different types of ions which are observed during the fragmentation of the molecules, that is molecular ion, fragment ion, rearrangement type of ions. We also call as a McLafferty rearrangement. Then multi-charged ions, negative ions, metastable ions. These metastable ions are short-lived ions. Okay. Isotope ions, that is chlorine containing, bromo containing compound containing ions. Okay. Radical ion, daughter ion, dimeric ion, adduct ion, and cluster ion. So these are the 12 different types of ions which are observed in the mass spectroscopy. Okay. So thank you very much.